So now how do we solve this equation? So the first thing that I want to do has absolutely no implication here, but it will come into play later on. What I do is I split pressure into two parts. I move myself away a little bit. This is written to it. I split pressure into two parts, a lowercase p, and later on the lowercase p will be associated with density stratification, density. And the Q in this equation is to do with all other effects and also effects due to sloping sea surface. So in this case, because density is all the same within the fluid, it's just a renaming. We call the uppercase P, we call it Q. This is the only change that we can. Let's have a look at the. Here we go. All right. You see here at the top are the equations. The only difference is that there's a Q in there. Okay? You also have a Q. The QS, the fourth equation actually that you can see here, is your equation for the boundary, for the surface of your fluid. This is what changes the sea level, and accordingly the pressure, the dynamic pressure associated to the sea level elevation. So you actually now have 4 equations instead of 3. So it turns out to be a little bit more complex. So how do you solve equations? The way to do it is you also split up again the Q into 2 components. Okay, you say, okay, I just start with taking the part that I know. This is Q at the time level n. This is the part that I know at the existing time level. And everything I don't know is I call a correction delta Q at the next time level n plus. So one you call the first guess, and then the other one you call the. And you insert this into the equations, into the first 2 equations. And if you do that, you can work out the first guess velocity. And the first guess velocity is called here with this U star is the first guess velocity in a grid cell, IK. So this was valid for any grid cell, but you can just write it like this. So it's the current velocity component, and you get a change due to the pressure gradient. This is just the first guess. This is not the final result, but this is just a time level n. What you still have to do is you still have to find the solution for the next time level. And it's still something like this. It's the first guess velocities. You still have unknowns here. You get the correction for Q, pressure correction for the next time. So how do you find these corrections? And I can already tell you the solution, because whatever happens in a fluid has to conserve volume. So because you don't all of a sudden create a vacuum, or you can't compress water. Seawater is incompressible. Water is incompressible largely. Okay. So now what you actually have to do is you have to plug in these 2 equations into the third equation, which is continuous. Don't get confused. You only need to do that once. And I'll show you many exciting simulations shortly. So this is the complexity, the problem that you have to deal with in oceanography. If you want to simulate, if you want to do some realistic simulations of fluid.